All right guys, welcome back to the channel. I'm Ben with Mechanized Cleaning Solutions, and today we're gonna put this blower back together from scratch. Okay, so you got a pile of parts here. No idea how it goes back together. I'm gonna walk you through it. We're gonna start with taking our two end caps. Well, you know what? Let's actually go through all these pieces. Okay, this is called the drive rotor. And this is where the pulley mounts, which is turned by the engine. The power is transmitted through this lobe. There's a gear that goes on this lobe, which mates up to a gear on this lobe, and this is called the driven rotor. So this is the drive rotor, which means the power comes in on this one. They're connected on the ends by a couple of gears, and that's what causes this one to turn. Inside of this case, and on this case, on this surface here, and on the back side, there's an end cap and an end cap. This is the dry end cap or the greasable end cap. This is the wet end cap or the wet end. This is where the gear oil is housed. And so you got a seal down in here and a seal down in here and a seal here and a seal here. And the seals are basically opposite both sides of this open cavity. The seals, this portion in here where the rotors are is where the air is moved. Outside the sealing surface down in there, up in this area, is where the grease goes on the grease end. And then over here, you have the seals go down in this race down here, and down in here, and up in this area right above it. This is where the gears, or the gear shafts pop out, and this is where this is all bathed in oil. This is an oil bath. And then this wet end cover is covered up by the oil case cover, I guess you might call it. And then you have the gears. Each one of these gears will be sitting right about here like this, meshed together. Here's all the shimming parts. And these gears fit together like so. And you have a couple of shafts coming out here. The shafts coming through the gears on these keyed shafts are these two shafts right here. There's a keyway into there, keyway into there. And then you got bearings on both ends. You got bearings that sit down in here on the grease side of the seal, bearing in here. So it's seal, bearing, seal, bearing. Same thing over here. Okay, let me get this set up and we'll start the first part of this procedure. Okay, so you want to start with both your end plates sort of flat down on the surface like this. And the first thing we're going to do is we're going to take our seals. We got 4 seals and 4 holes, and we're going to put our seals down in here. Now, they call for sealant, which you should do. I never do that. I just like to use WD-40 on everything just to kind of help things slide together. So I'm going to go get a seal tool. We're going to just put a little bit of oil on these, a little bit of WD-40 to help these seals slide in a little easier. Okay, we got a seal. Got a seal input tool. This is just you got different size seal tools. I think I got this from Napa. It's got a little handle. Put different size seal installation tools. But what you want to do is you want to bear down evenly around the entire face of the seal. So you could use a socket, maybe with an extension, tap it in with a hammer that way, or you could use one of these. I'll just go ahead and use the seal tool. Let's see about getting this first seal in there. Drop that puppy down in there. Now, I don't really know if it should go this way or that way. I mean, to my mind, I would kind of like, you know, there's a little spring on the inside of this race here. It'd probably be good to have the oil on this side, but honestly, I wouldn't want to try to tap this in this way because I don't think that'll work good. So I'm just going to go ahead and put it in this way. I never really had any problems with the seals going in the wrong way. We'll see what happens there. put that puppy all the way down. Here we go, seal number 1. We'll do one more on camera here. Just want those seals all the way bottomed out. Here we go. Okay, we got all our seals in, all 4 of them. Okay, step 2, after getting the seals in. Now, I think there's multiple ways to do this, and I don't even really know what the best way is, but I'll just tell you the way I always do it. First thing I do is take the housing, lay it on its side, and I'm gonna take the gear end coil, or sorry, the gear end cover. I'm gonna place it on and just zip it down with like 4 bolts, just to get the end plate flush with the housing here. The gear end only, not the greasable drive end underneath this. We want the one that has the oil, which is gonna take that cap. And that's the one you wanna use. So there's a couple of dowels on the ends here that are kind of tight. Just give them a little tap down, make them flush, and then we'll go ahead and put in 4 of our little cap screws here just to hold the cover in place. Now what we're gonna do is take this whole thing, flip it upside down, and set it up on a couple of blocks. Like those blocks right there. What we want is a little bit of space underneath this surface here to allow the gear shafts to stick out without hitting the table. So we just set it up on a couple of blocks, and the blocks are gonna be resting about like here over and here over, just letting the shafts protrude through while this is upside down sitting on those blocks. Okay, like so. So we got the blower housing with one end plate on, the gear end sitting down below with some space for the shafts to stick out of the bottom here. Just like so. Now what we're gonna do is we're gonna take the drive rotor, which on this blower, if this thing is sitting like this in the machine, the drive rotor's on the right side. We're gonna drop in the drive rotor with the drive shaft, the pulley shaft sticking out here, and then the other rotor is gonna go in down here with its idler shaft sticking out on that end. I'll show you what that looks like in just a sec. Now you just wanna be careful when you're dropping this rotor down in there. You got a brand new seal down in there, so just be careful as you're going down through that seal. There we go. And you're gonna feel the seal grab the lip, and then we'll just pop it through. There we go. Okay, I'm gonna use both hands to get this other lobe in here, and then I'll show you what it looks like when we're done. Okay, here we go. It just drops straight in, and then when the diameter of the drive shaft goes through the seal, it'll be real tight, so you just gotta, it'll pop down that last little 1/4 inch, it'll drop right down. Just be careful when you're going by that seal so you don't blow that seal out or rough it up or scratch it up. Then you got your little shaft sticking out of the bottom there. Okay, so that's that step. Now the next thing we're gonna do is we're gonna take the dry or the greasable end cover, and we're gonna place that down over both of these rotors with the idler shaft on this side sticking through this hole, and then the drive shaft here sticking through that seal. Oh, and real quick, what I like to do is just hose everything down with WD-40, get a nice rust preventative, lubricating wetness all over this thing. It helps with reassembly, and it also helps keep rust out of this thing while it's sitting and exposed to the air. All right, let's see if I can just do this one-handed. I really need a filming buddy. Oop, that's not gonna work. Let's do it this way. So really, I'm just trying to be careful of not nicking up that seal. There we go. Now we're sitting on the seals, and all I gotta do is give this thing a little nudge to get it down over the lips of the seals, and then we're flush. So give me 1 sec while I do that. Now we're just going to set the cap down over the dowels. And put a couple bolts in. Both end caps on. Now the rotors, if we were to lay this thing down, sitting on its side, the only thing holding those rotors up in this housing, they wouldn't fall far because they have very little clearance on the sides as you saw, but those seals are the only thing holding these rotors in place. So before we go ahead and flip this thing over, we're going to go ahead and install our bearings on both sides. That'll provide extra support and take a little bit of the pressure off of those seals. Put the load, the lateral load on the bearings. So now you have 3 different kinds of bearings in this thing. You got 2 identical sets of double row ball bearings. These go on the gear side, Then you have 1 single row ball bearing, and then you have 1 roller bearing, which is designed. This one is like high speed friction, but it doesn't provide a lot of lateral stability because there's just a single row of ball bearings. But this one has roller bearings and is much better for providing lateral stability. If you have, like, say, the drive shaft coming out, right, and you have a pulley on here and you have belts pulling off to one side, that's the one that the roller bearing goes on. So this roller, or the single row ball bearing, goes on the idler side because this thing doesn't really have a lot to deal with, a lot of lateral forces. So we got to make real sure that you put the cylindrical roller bearing on the same side as the drive shaft over this tail shaft sticking out here. Hose these things down real good with some WD-40. Get them nice and wet. These bearings are really never a good time to put in, so we'll muddle through here. So you can see here we've gotten it started. The shaft is in the middle, but these are, they're not a full interference fit, but they're tight. They take quite a bit of finagling to get them down in there, but with this bearing needs to be bottomed out in that hole. So we're gonna keep pounding away on this thing until we get it. I'm not gonna bother filming this whole thing. I'll just show you when we're done. Okay, we got the idler bearing down flush with the top of the shaft. And now we got to work on this one. So I'm going to go find a piece of steel pipe or something with the same diameter as this inner race. I can go over this and I can pound this one down. Okay, let's use the forklift here as a little improvised tripod. There we go. A little better. All right, guys, how's that? Now better? Yay! Clap your hands, everybody. Okay. So I found a good way to do this. This is not too tight. Got a punch and a hammer, and I'm just kind of working this thing down in there. Both sides. Thank God these bearings aren't machined super tight, because I don't know how this fucking thing would go in there. Just alternating back between sides. Not getting too crazy with it. Okay, we're at the first shoulder. All right, she's bottomed out. I think I'm gonna go ahead and put a little on this one too, because I don't think this one could, I think this one could go down a little further, maybe. Just wanna be careful not to hit those balls and nick that metal up. Yeah, that thing's all the way down. Okay, all right, both bearings on the greasable end are in. It gives us a little more support on our rotors. Cool. Just making real sure this thing's totally down. Best to take your time through it. All right, let's have a look here. So it looks like this one is more or less flush with the top of the shaft, the output shaft. And this one appears to go down just like maybe like an 1/8 or maybe a 1/16 lower than the shelf. Okay, now that we got two bearings in, now we can flip this puppy back over and put those bearings on the other side in. All right. Okay, now we got the same situation going on. Now we got the tail shaft sticking out the bottom, and we got the two gear ends sticking out of the top. All right. Okay, so we got the bearings ready to go in. They're sort of sitting on their interference fit on the shafts. The first thing I'm gonna do is get them down flush with the tops of the shaft, just with a straight pounding tool that'll bear on the entire thing evenly. Then I'm just gonna work on, probably with that punch, the same situation, working the entire bearing down into the whole groove, and just kind of finagle my way through it carefully. Yeah, those are fucking tight. Oh, and of course I hosed everything down with WD-40 really good, just to kind of help things along. All right, we're flush there. And we're flush there. Now the not so fun part. I'm gonna get me a metal hammer. Give this thing a little more punch. Okay, what I did was just went and got me a big old 1¼ inch socket. This is a 3/4 inch drive socket. Something that'll just allow that shaft to come up through here. As I tap on that inner race, let's see how this goes here. Now, something to know about this is right now, all of the resistance is on the inner race. This is just floating out in space. Once this outer bearing race makes contact with the housing, there's gonna be resistance pulling up on this thing. So I'm gonna wanna find some way to put pressure on this inner race and also this outer race so I'm not stressing the ball bearings. So for now, until I get this thing into the housing, I can use this socket and just press on this inner race. Hopefully. Getting there slowly but surely. Definitely nicking that shaft up. I don't think I want to keep doing that. Make a little piece of sandpaper to that shit. We'll just do it like this. Okay, we're making contact now. I want to be really careful. Maybe give this a little help on the outside. So it appears that just pressing on the inner race seems to be working for now. Shit makes me nervous. The last thing I want to do is trash this blower. I'm going to do this for a bit longer, then I'll bring the camera back. Okay, we got the drive side bearing on the gear end down. That just actually took about 45 seconds. It wasn't too bad. And what I did was just basically hitting here, hitting here, hitting here on the inner bearing race all the way down. And it bottoms out and it's just not barely flush. Like the bearing sticks up maybe a 16th, not even a 16th, like less than a 32nd, maybe a 64th. It's just barely, you can barely tell that it's a little higher. And then this bearing is held in by a plate that bolts down around here. So I'm gonna pound this other one down, and then we'll come back and I'll show you guys the finished product. Okay, both bearings are down. That just took about a minute, maybe a minute and a half to do that side. Just pounding back and forth on both sides. And you know, thank God that these bearing races are hardened. They don't seem to, it's really nice metallurgy. Those things took like 0 damage. I was hitting them with a metal punch. You can see ever so slight scuff mark, but if you feel it, just smooth as it can be. Okay, bearings in, no damage. Yahoo. Yahoo. All right. Okay, next step are bearing retainer plates. Just go over the bearings and I guess keep the bearings from working their way out. There's a bunch of sandblasting grit in these threaded holes. So what I'm gonna do is put a little WD-40 in each one of these holes, clean them out with the air compressor. Give me a sec, I'll be right back. Okay, there was a ton of sand in those fucking bolt holes. And there's probably a bunch of sandblasting grit down in the bearings now, which is probably gonna crush the bearings, kill them. But we'll have that cow when it comes time to have that cow. All right. These are steel hardened steel bolts in a steel housing. I don't know what the torque specs are, but pretty tight and not tight enough to break the head of the bolt off. I'm gonna zip those down. Back in a second. All right, bearing plates in. Next, we got to put a couple of spacers on. Now you have these spacers. You'll notice that there's a chamfered edge and a non-chamfered edge. The chamfered edge goes down towards the bearing. Now this spacer here is what the shims are going to go on. We also got a couple of shaft keys we got to put in. So the shaft keys got to go in next. Gently tap these down and then tap them in. Now those shaft keys need to be all the way in the shaft keyway. If they're not, these things, these gears, when these gears go on, they're really hard. They're like a super tight press fit. So that having every little bit you can of the slop taken out of this really helps. So, yep. Now we're gonna start with the base shimming. So the shims also have a keyway. These two shims are going to go on the drive side. And these three shims are going to go on the driven side. So this is what we're going to start with for the clearance. And you just want to make sure the shims are clean. There's not like hair, dog hair, whatever stuck to any of them, because the shim thickness is really important. In fact, I'm going to take these back off and get them wet with some WD-40 and take an air hose to them and just get any little bit of sand off, and then I'll put them back on. We want the shim thickness to be, we want all the shims compressed and with no junk in between them. Okay, we got the shims cleaned off. This thing's ready to take gears. Now for the gears, we got to figure out how to time this thing. Here's how we do this. For this, we're going to use a marker and a straight edge. And if you look at this gear, you got a keyway in both gears, but these gears are not the same. If you draw a line straight from this keyway out to the edge of the gear, on one of these gears, that line is going to wind up being between two teeth. In fact, it's going to be that notch right there. On the other one, if you go halfway between that keyway, straight out to the edge of the gear, that line no, I'm sorry, it's gonna come out, on this one it's gonna come out, well, let me grab a straight edge. Get perpendicular here. Here we go. So we'll cover up that keyway. Okay, so yeah, this one comes out on the tooth. So if you look right down in there, one tooth, that tooth is our money tooth. On this one over here, it's gonna be a gap, it's gonna be between the teeth. Those are the two teeth that are gonna mesh. So it's easiest to do this by actually taking a marker and putting a line on here, because when you start putting these things together, because these teeth are not straight cut, they're helical, as you pound these gears down on the shaft, they also have to rotate a little bit to stay meshed relative to one another. So what I found the easiest thing to do is go ahead and mark them up first. Get your lines on it. This one's already had a line on it from whenever. I don't know, I might have marked it when I took it apart. This one, no hole. Yeah. So I'm gonna go ahead and mark these with a marker so we can see what two teeth, what tooth and what valley need to mesh. No, I'm an idiot. It's wrong. Okay, so coming off of one, and I can tell because they're ever so barely marked from the last time I did it. So there's the residual mark from the last time I did it, and there's also the residual mark from the last time I did it. So theoretically, this mark here, this residual mark, comes in like so. And is perpendicular exactly to this keyway here. So that's how they go together. One key or one shaft is, one keyway is pointing like straight up and the other one's coming in at a 90-degree angle, if that makes sense. So that's the way these two gears are gonna go on. We're gonna put the drive gear on first, all the way down onto the shims, and then this gear, now the way I always did this before is you gotta take, and you gotta follow this tooth around right here and color the top of this tooth so that you're real sure that when you're looking at it like this, that tooth, the one that I marked here, let me, sorry, I'm trying to look at the lens of the camera and what I'm doing at the same time. That's our money tooth right there. That edge right there, coming off at an angle, is what needs to mesh up with that tooth. So that when this baby's fully put together, they mesh up perfectly. So you see as it comes out, it's got to rotate out. It's just tricky. Okay, gear number one is going to go on. So you want to make real sure you got your best guess for the shims. And the best thing to do is sort of divide. If you just have a pile of shims and you don't know how many shims you had, how many total thousandths of thickness you had on one side or the other from the take apart, just split them up evenly. And we're going to be off a little bit. And what we're going to have to do is put this all back together, tighten everything up, and then we're going to check the clearances of the lobes, and we're going to be off. We check those. I'll show you how to deal with the feeler gauge. And then what we do is we take the gears back off, move the shims around until we get these gears relative to each other so that the lobes are perfectly 90 degrees. So this next step is just going to involve putting this gear down on this shaft over the keyway and just pounding her down until we see underneath that the gear is just squishing all the shims nice and flat. And it's totally bottomed out. And you can see how fucking hard these things are getting on and off. And then we have a bolt and a retainer. Okay, so now, following this along, we're gonna line up our, we have our line following our tooth around. We're gonna line up this tooth with the ink on it. Sorry, following the line all the way around. We're gonna follow this tooth and we're gonna notch that end into that receiving tooth. So kind of a pain, but I got it started. You can see how coming across, we got the two teeth meshed up there. See that? Okay, that's what you want. All right. Now, right now, because we're on the ends of the teeth, and we got basically whatever that degree of rotation is off of these angled teeth cuts, you know, the lobes are totally not 90 degrees. But as this thing goes down, the lobes are gonna get closer to 90 degrees and the clearance on both sides is gonna open up. Right now, they're basically touching on one side and there's really, this thing can't really move because they're all jammed up. But as this gear goes down now, the clearance on both sides of the lobes will open up and even out. But they're not gonna be perfect until we get the shimming underneath correct. Okay, pro tip. Now this is probably a lot easier to do if you had some kind of like hydraulic press or something like that. But what I want to show you guys here is that right now these things spin, but they won't make a complete revolution because the timing's way off. So right there they hit, right? The lobes hit, and then over here, there's only maybe, I don't know, maybe 60 degrees of movement there with this gear sort of like 30% down. What you want to make sure, save yourself a lot of trouble, is that you just always have a little bit of play here as you're putting this second gear down. So just every hit, check it and make sure you're still loose. And what you don't want to do is have it bumped up against one of its limits and then hit it. You want to have it somewhere out here where it's got some play both ways, then give it a good whack and then check it again and just make sure it's loose as you're going down. So we're still loose, we're good. And then what should happen, to know that we have this right, we have the correct two teeth meshed together, we're not off one tooth. If this thing will make one complete revolution, once I get both gears all the way down, you're good. If you're off by one tooth, you won't even be able to make one complete revolution. So that's how you check to make sure that you have your gears all the way down or your gears meshed in the proper teeth. Still loose. Now the hard part is not done yet. Our lobes will make one complete rotation, but now we need to check the clearances. Cool. And now what I like to do before moving on is, in order to get good readings on the clearances, this thing's pretty much got to be all bolted back together and tight with no slop in it because it could affect the clearances. So what I'm going to do is go ahead and zip in the rest of these bolts, put the two mounting feet on the bottoms, and basically put the case all back together. And bolt it all back together. Tap on both ends, kind of get the lobes basically centered in the housings, get everything to where I think it's good and halfway, and then we're going to start taking our feeler gauges and checking our clearances on the inside. Let me give me a minute to get all that set up, but all I'm going to do is basically put all these bolts back in and put these feet back on. Nothing too complicated. Okay, the sides are all bolted back on, the feet are on, everything's nice and tight. When I got it all back together, this thing, when I bolted it all back together, it was totally seized up. It wouldn't move at all. What happened was these two lobes in here, one of them, the one on the left side. Now, as you go through multiple rebuilds, you wear a little bit of metal away, sandblasting, scrubbing, or whatever, and there can be slop. This thing's been rebuilt. This is at least the third time, maybe the fourth. And, you know, when you take a wheel to it or sandpaper, you start taking little bits of metal off here and there. And there's just a little extra bit of play. And what happened was the lobe was just sort of shifted back this way a little bit, and it was rubbing this lobe over here. The flat face on this side was just rub it up against the case a little bit. So all I did was take a hammer on the shaft back here and just put a socket on the shaft and just gave it a good tap and just sent the whole lobe and the gear and everything. Just sort of took it off about a thousandth or a couple thousandths, just moved it ever so slightly, and then totally moving freely again. Like I said, not a lot of room in here. Okay, these are the specs for this blower. This is a 4/005, meaning we got 4-inch gears and we got a 5-inch wide lobe. That's this model. A 4/005-21L2. That means two lobe rotors with one drive shaft on the left side, number 2. That's this guy. Okay, so we got drive end clearance. This is the drive end over here where the pulley goes, the drive pulley goes. There's a clearance if you look down in here. Right down in there. There's gonna be a little tiny gap between the lobe and the back wall. That is the drive end clearance. This one should be, looks like 4 thousandths to 9 thousandths of clearance. The gear end, which is this end, meaning the lobes up against this plate here. The ends of the lobes should be 4 thousandths to 6 thousandths on the gear end, and it gives you a total reading of 10 to 14, but whatever. Basically, you get them halfway in between there. These two numbers aren't critical important. As long as they're not touching, you're good. What really matters is the interlobe clearance. Then you have tip to dowel and tip to port. So you have here the rotor tip right there, right at the port opening. That would be considered tip to port. If you rotate this lobe over, say 90 degrees, so that the lobe end is out against the dowel, that's actually the dowel right there. So tip to dowel, there's a clearance there, but we can't change that. All we could really fuck with is the interlobe clearances, meaning how much gap there is in between the lobes, if that makes sense. So we're really gonna be focused on just making sure they're not rubbing on either end of the plate. As long as they're not touching, we're good. And we're gonna focus on the interlobe clearance. The interlobe clearance should be 12 to 16 thousandths. So ideally, we wanna be 13, 14, 50. We wanna be 14 thousandths all the way around. So we wanna get a 14 thousandths shim or a feeler gauge, and we wanna be able to slot it into that gap there, rotate the lobe over here, check that one down there, then flip this thing upside down and check both sides. We want them right at 14 thou. You know, if we can get a 14 thou feeler gauge in all 4 of those locations, we're good to go, ready to bolt her up. All right, guys, let me go get the feeler gauge and we'll get this going. Okay, so you need one of these long feeler gauges here. You can get these from Napa for like 30 bucks. And it's got a whole bunch of different feeler gauges of different thicknesses. We're looking for the 14 thousandths one. That's this one right here. No, that's, where am I at here? Oh, there we are, 14. That's the one we want. This little booger right here. That's our money feeler gauge. So I'm just gonna go ahead and try to stick this light like right there so we can see what's going on here. So what I'm gonna do is just orientate these lobes on this side over here so I can see where they just sort of come together there. And what I'm doing is that whole side right there, all the way through that whole motion where that lobe, where the right lobe goes into the sort of middle of the figure 8 of that lobe, I'm just gonna sort of check that whole section right there. And if that feeler gauge will slide through that whole thing right there, we're good to go. Let me put this phone down real quick. Okay, we're good on the right side, but we're not good on the left side. So let me show you what I'm talking about here. So here, I can stick the feeler gauge down in there and then rotate the lobe, and it's fine. I can pull this thing right out. On the other side, we do not have 14 thou. So if I go try to stick it in where the lobe's made up on the other side, they pretty much hit right away. So we're short on that side. And basically what I do is I just stick these down in there, then rotate the lobes and see what happens. and then bam, it just stops. Can't really see that, sorry. So we got not enough clearance on this side. So that tells me that what needs to happen is this gear right here on the left side. If this one doesn't move at all, this one needs to rotate just ever so slightly that way. It needs to open it up just a touch. Now, if my theory is correct, I should be able to flip this thing over and then have the exact same problem on the opposite side, because what's happening is, since the lobes are essentially, let me put the tripod on real quick so I can explain what I'm talking about. Okay, so assuming that the lobes are not distorted and they're machined properly, they should be right at 90 degrees. But if they're off a little bit, we would not have enough clearance on one side, like say the top left, like if it's off like this, right? Just a little bit like that. Then you could see how the upper left quadrant of this square is slightly less than 90 degrees, and so is the lower right quadrant of this cross I'm making with these two bolts. Slightly less than 90 degrees, lower right and upper left. Now conversely, if we had the problem going the other way, the lobes would be orientated the wrong way. So what I'm gonna do is flip this blower upside down and then see if I have the exact same problem. I get the 14 thousandths, whatever, shim in on the left side, but it stops on the right side. And then I know we got an issue here. We need to go ahead and, looks like we would have to, if that is the case, if I'm looking at these helical cut gears, what would happen if I pull this gear out? If I pull this one out this way, it's gonna rotate that way relative to this gear based on the way these teeth are cut. So as I pull this thing out, it needs to be able to rotate this way as I'm pulling it out, because the teeth are cut that way. So if I want it to go the other direction, that means I got to take a few shims out behind this one, maybe like one of the thinner, a couple of the thin ones. Take them out of this one, put them behind this one. That'll cause this one to go in a little further, which will cause it to rotate a little bit more to the left as I push it in more, if that makes sense. So as I push this gear in a couple of thousandths this direction, it should rotate that way as it's going in, because this one won't be moving. And that's how we'll open up that clearance. But let me double check the other side and see what's going on here. Okay, so what we thought, or what I thought is the problem, is exactly what it is. So we were good on this side and we were bad on this side. Now this thing is flipped upside down. Let's go and stick our feeler in here. Tink, it stops on the right side, what is now the right side. And if we go to the left side, check the other side of the clearance, bam, good to go, no touch. So we got some shimming to do. Okay, let me get this thing flipped back over. We'll get ready to yank these gears off and I'll figure out what I have to do here. So what I need to do, now if I'm just looking at the front of these gears here, you can tell very clearly that the gear on the left is sticking out just a little bit from the gear on the right, because I have way more shims behind this one than I do this one. So we can tell these things are machined so closely just right out of the factory. See that, just that little bit of gap right there, just that little bit of meshing difference. So the gear on the left is sort of out just right there. I get my fingernail on it. There's a very obvious shelf of metal. So what I'm gonna do is there's like 4 shims behind this, and there's 2 thick ones and a couple of thin ones. I'm not sure what the total is, I didn't measure them. But I'm just gonna take one of the thick ones off of this side and put it on this side. That's gonna be, so if it's might be a 5,000th shim or a 10,000th shim, whatever it is, it's gonna be a total of 20 thousandths difference, because I'm taking 10 off of one side and adding it to another. Now, I guess what the manual says about this is that for every thousandths of shim you change on the gears with shims, cut that in half, and that is the difference of the clearance you'll get inside your checks. So if I change it 20 thousandths out here, if I take a 10,000 shim and move it over here, creating a total 20 thousandths different, there will be a 10 thousandths difference inside where I take my measurements. Don't ask me why, I'm not a mathematician. That's just what the book says. So that's what I'm gonna do. I'm gonna pop this gear off. Actually, I'm gonna pop both of these gears off. I'm gonna take one of the big shims. There's some, you could tell them, it's like some of them are pretty thick and there's different thicknesses of shims. I'm gonna take one of the big ones and just move from this side to that side. And then I could go and measure and find out what the difference is and all here and figure out exactly how many shims I need to move. But I've done this enough times. I just know that one of those thick shims, and if I get those two gears more flush, we're gonna be all right. And that's gonna be good enough for what I'm doing here. Maybe not perfect. I'll get it as close as I can without wasting too much time on it. But honestly, I just got too much shit to do. I don't wanna waste any more time on this blower. So that's what I'm gonna do. I'm gonna zip these off, get the jaw puller on here, get both these gears off, move the shim over, put them back on, hammer them home, check it, and hopefully we'll be good. All right. Okay, so we're getting ready to pull this left gear off before we pull the right gear off. Now, the thing to know about this is when you're doing this, when you're taking these gears off, is because the gears are cut helical, don't just put this thing on here and zip it out, because what'll happen is these gears will bind up. What'll happen is the fact that the gears are at an angle, they'll start interfering and then they'll get stuck and you gotta like pound it back in, or you bend up the teeth. So what you wanna do is just make sure you always have a little bit of, it just can move. As soon as it stops moving, stop, back it off, and then get it to where, and then get it back into its movement range before you continue on trying to pull this thing apart. And before I do this, I'm gonna rotate this thing around and just mark my teeth so I don't lose that reference point. There's my marker. There we go. All right, can you guys still see? Yeah, okay. So there's our two teeth meshing right there. It's always a good idea to lubricate up the threads on these pullers with a little bit of oil before you get into this. Otherwise, sometimes you can strip out your bar puller thread. Okay. So what I'm doing is just going to be checking for movement the whole time. So I'm checking if that's where it's hitting. So I'm just going to go away from that spot and continue on. It's going to be hitting a little farther away. I just want to stay away from that spot where it's hitting. Okay, now that one gear is off, I can just go to town on this thing. I can just literally yank it right off and no harm, no foul, nothing to interfere with. Okay, gear two's off. Okay, I got some calipers here. We're gonna measure our shims. Turn this puppy on, zero it out. We're gonna be working in inches. So what I'm gonna do is I'm just gonna grab this whole shim stack and measure the thickness and write it down. Looks like we got 16.5 thousandths of shim on the left side. Nope, there's one more shim on there. I was wrong. We got way more than that. Let's see, let's do that again. Measure the thickness of all these boogers. Missed a shim. Looks like we got 27.5 thousandths of shim. That's quite a bit. So yeah, that was a big 10 thousandths thickness one that was still on there. Let's check the other side, see what we got on here. 20 thousandths, my bad. We got 20 thousandths of, of shim. So we got 20 thousandths on the right, and looks like 27 thousandths on the left. All right, let's go and move one of the big ones over to the right, see what that gives us. That gives us a total of 31 thousandths on the right. 16 on the left. So I'm gonna go, I'm gonna mess around with some, with a piece of paper and get some exact differences here. Give me 1 sec. Okay, we were pretty off there. With the lobes hitting on the 14 thousandths feeler gauge on the left side, we were shimmed at 27 thousandths on the left, meaning this shim pile was 27 thousandths thick, and the right shim pile was 20 thousandths thick. So we were plus 7 thousandths shim on the left side, on the left gear. Now, if we move 1 10,000th shim over to the right side, we go from 27 down to 17, and we go from 20 to 30. But we have a bigger difference than that to worry about. So we have, essentially, we went from plus 7 to the left, now we're plus, what is that, plus 13 to the right. That's a total of 20 thousandths difference, right? So we got the difference here of 13, we're positive 13 to the right, right? And we used to be 7 to the left, plus to the left. So now our total difference is going to be that 13 plus that 7. That's the total amount we're moving. So that's 20 thousandths that gear is going to go in, which is going to equate to a 10 thousandths difference. If they say whatever your difference of, what you're doing on the gears, if your total change is 20 thousandths, then that's going to equate to a 10 thousandths difference clearance in here, because apparently it's cut in half. I don't know why that is. I mean, it has to do with, I guess, the angle of the teeth on the gears, but that's just what the manual says. I don't know how accurate that is, but we were hitting pretty high. Now, I just know this from experience. I mean, that thing was contacting like right at the top there. It wasn't even getting like kind of all the way down before it was hitting. I mean, it was off pretty good. So, we were trying to go from 14. I probably could have got a 4 thousandths in on this side, and I probably could have got a 20 thousandths in on this side. So if we take 10 off, move it over, we should be pretty close to 14, 15 thousandths on both sides by moving that one shim, that 1 10,000th of an inch shim over to the other side, creating a total 20 thousandths difference. Now, I know this is all, look, this shit barely makes sense to me. I'm a freaking idiot, but I barely understand it, and I probably don't even understand it. But this is going to get us close, and we'll see. I'll put it back together, and we'll see how it turns out. We'll get the feeler gauge in there. If we can get a 14 thousandths in on both sides, or if you can get it in on both sides, then you certainly can on the bottom also, because basically it's the same. So, yeah, I'm going to go ahead and stack these shims back on the shafts, get the gears back on, pound them on, and then we'll stick the feeler gauge in there and see where we're at. All right, guys, thanks. Okay, got the gear on the right back on. Now I'm going to put the left gear back on. I got my tooth marked, if you can see it there. This is always not fun and lame. Okay. Okay, teeth are meshed. So now we're hitting there. Before I start whacking this in, I'm just going to back it off, get it sort of in a different space there. Checking. Checking. All right. Now the rotors haven't shifted in the case at all. They're still not rubbing on the fronts of the backs. We got nice clean movement. We're not hitting anywhere. That's what we want. All I can hear is metal on the teeth here rubbing, and then just those things are barely touching. So let's get our 14th thou in there. See how we're doing. Yep, rotates in. Yeah. Seems like there might be a touch more room on this side. In there, nice clean lobes, look at that. Yeah. A little bit of a light coat of oil on them. Keep them from rusting until we wind up using this thing. Okay, we got a seal for the drive shaft, and we got a dust cap or a grease cap for the idler side. Let's go have a look here. So we're just gonna tap that guy in there. Get that seal tapped in. Okay, stand. Looks like we rolled up the edge of the seal a little bit, and that sucks, but fuck it, I don't even care. All right, that's that. I'm gonna go ahead and screw in the grease fittings. Okay, let's bring you up to have a look here. Pressure relief, grease input, grease input. If you don't want to replace an oil leaky cover, make sure you always go around your bullet holes. Okay, we got a sight window. We'll put that on the bottom here for the oil sight window. These things take a freakishly small amount of oil. It's like, you know, they filled up with synthetic oil up to there, and the gears are just like, you know, freakishly small amount of oil, but apparently you're not supposed to put any more in there than that amount. Don't ask me why. It's like you're basically just, that oil is like super viscous and thick and sticky in the rest of these holes. Okay, got all but one plug back on. I'm gonna fill this thing from some oil. We got some of this HEC 100 synthetic lubricant. Yeah, just put some kind of oil in there. This synthetic stuff's good. You can use it and leave it in there for years and the shit never breaks down. It's pretty good. Just pour a little bit. So there's our sight window right there. This thing doesn't take much. It's pretty much gonna I think that's pretty much gonna bring it to the full. Oh, I think I see a little bit. Yeah. There we go, right about halfway there. It's perfect. Let's spin that over a little bit. That'll put all the oil up on the gears. Okay, grease gun reloaded. You know why that grease is coming out of that hole? I put the seals too far down in. They're only supposed to go down flush with that first surface. But whatever. Live and learn. We'll fix it on the rebuild. Probably have to rebuild this one sooner because shit's gonna get down in there. But that's okay. Okay, full of grease. Yeah, I thought the seals had to go all the way down, but that is apparently not the case. We'll just have to keep this thing packed full of grease, keep water out of there. And, well, whoop-de-doo. All right, I'm gonna clean all this shit up, and we'll say goodbye. All right, properly timed. New bearings and seals. Ready to do some work, just got to give her a little paint job. Keep the rust off of her and we're done. All right, guys, that concludes how to rebuild or reassemble and time a positive displacement roots blower. All right, guys, have a good night. We'll see you soon. See ya.